Everyone, my name is Zahin Ashraf bin Mazlan. Today I'm going to demonstrate and explain a bit on the lab assignment that I have been working on using the Xcode Apple Developer IDE tools to create an application using Swift UI. The objective of this exercise is to build understanding on the feature Xcode IDE has to offer to develop iOS application. We learn to create a new project in the IDE, work around with its interface, storyboard, program files, and also we'll have a chance to build application with using Swift programming language. In this exercise, we'll be going through some of the imported libraries, for example, like using UIKit, core location, and core data to run few of the programs that have been built for this demonstration. Also, for the sake of this demonstration, we'll be using a simulator. First of all, we need to build the simulation, and we can see that the program has been successfully built and start to fire up on the simulator screen. We can see that the application is running and the static table view cell is shown. This is set as the initial view controller. From the screen, we can see that there are three applications, two application and one database, three program in total. The first one is the BMI calculator. The second one is the GPS coordinator, and the third one is the database, basically for the user registration. Okay, this static table view cell also is embedded with the navigation controller, meaning that it can go back and forth to the in-depth pages, similar to like the settings that in your phone. Okay, for the BMI calculator, this is the default interface for the BMI calculator. Basically, user have capability to insert their height, their weight, and also this has the feature to set in the metric unit or the imperial unit, and the program can calculate your BMI can also can show you the result, the healthy prescription result based on the height and weight that you entered. For example, let's see, since the switch UI is toggled into the metric unit, I'll put example 1.67 for example for my height, and for my weight I put for example like 57. And when you hit calculate BMI, your BMI is shown as the two significant digit number in double, and also the result is shown as normal. And if you press the request healthy prescription, it will compare with the ideal prescription of 1021. Basically, we will follow the table in this one. This is the reference table that we're using for for building this application. So the ideal BMI is 21. Okay, so back to this simulation. If I press request healthy prescription, you can see that the aim of my weight should be 58.57 kg. As mentioned, if I toggle it to the left to the empirical unit, my height that I input and also my weight that I've input will be changed to the empirical unit. And also you can see that here for the prescription, the result will be converted also into the empirical unit. Okay, then for the GPS coordinator, we can see that there's a blue highlighted dot. It can be shown in the map, showing that this is the location of the host server for the Xcode IDE, and the default zoom is set to 1000 meter. Later we will go through in brief the codes that how to set this parameter. And finally, for the database, you can see that I've been testing with 3 sample data, Ali, Nor, and Test. Basically, if you hit the plus button here, you will be prompted with the window to add a person with name and age. For example, if I type my name, Zahin, my age is 27, I will hit post, it will stored in the table view list. And even if I've closed the application and run it again, the record just now will be saved here. Means like they save in the database instead of just showing on the application, and if you close the application, it will be gone forever. So meaning that the database is working. For the explanation on the code, we explain a bit based on the demonstration that we done using this simulator. For the BI calculator, you can see that there are a few outlets that will be linked directly to the UI kit. For example, like the UI text field, UI label, and also the UI switch, and UI button. Okay, next we seeing about this override function called touch beacon, whereby if you by running this code, you able to toggle the keyboard UI keyboard off when you touch the touch other than the text field. For example, like if I touch here, the UI keyboard will be drop down. This is the function of this line of code. And then we can see that um, these lines of code, basically uh, we change the input value of from the empirical unit to the matrix unit or vice versa based on the switch button that have been toggled. For example, like if this switch button that has been toggled to the right, which means that it's on, the sender is on, means like the calculation will be calculated in the matrix unit. Else, in the off, means like the sender is off, the input for the height and weight will be calculated in the imperial unit. So you can see that for the this basic conversion is done, whereby 1 inch is equal to 0.0254 meter, whereby 1 pound for the weight is equal to 0.453592 kg. And yes, for these two lines, it just show you the uh, the placeholder for the text field. You can see here in the height inch and the weight lbs, and also the height meter or weight kg, depends on the placeholder being set for this function. Okay, next we go to the calculation for the BMI. Basically this is the formula: weight divided by height square, and we going to calculate it in the double value. And we can see that I'm using this table here. You can see that this is a table reference that we're using to generate the calculation for the BMI based on the range on this table, shown in this table. So even for, let's say, if the user doesn't input either height or weight or both, this result label will be shown. Please fill out your height or weight. You can show here. If I just click calculate BMI, please fill out your height and weight. Okay. Also, for the last section of the program is for to calculate the healthy button, the request healthy prescription button. Next, we will go through the geolocation, means like for the GPS coordinator. Here, this one. So basically, for this application to run, you need to import the co-location library and also the mapkit library. These two library need to import in order to generate the map and also to pinpoint the location of the user on the map itself. When dealing with the geolocation, you need to play around with the authorization, the permission to access the GPS services in your phone. So what I did explore is that check the location of the user, means to get the permission whether the location services in their phone is on or off, and even after they enable their location services settings in their phone, they still need to, like, the application need to have permission to access, uh, whether always authorized or just authorized when in use. For example, like say, uh, for this simulator, we can see that uh, for this application, this service location is on. Okay, for this program that I'm running right now. Okay, when fire up the application, the code we run is this line of code. The override function view did load, where we will check the location services whether it turn on or off. Check location services is not the application location services, but the device location services here. This one. Okay. So if the location services is off, basically it will the user to turn it on. I just put the alert on the info.plis, whereby this is one for the privacy location where in use. I just put, hey man, this is why we need your location. So this is alert will prompt if the user is not enabled the survey location, putting up the application. Okay, when assuming that the application, or assuming that the user already turned on their service location services setting in their phone, we will the program will check for the location authorization. For this code, for this application, there is five cases that have been considered. Okay, just go through for the case one. For the case one, authorized in use. Basically, this case is when we need the authorization, when we ask the user for authorization to use the GPS tracking to locate their location on the map, only when the application is active on the screen. Okay, so for the second case is for denied, meanings like when they already enable their location services on their phone, when they are boot up application, and when the prompt saying that they want to track the location, then user has option to uh, allow or deny the request. The third one is not determined. The determined meanings like if the user already turn on the application and turn on the location services and run the application, the GPS locator application, but then also they turn off the location services. So this case not determined will be I choose. Okay. Then the restricted case, restricted is when the phone is on the parental control mode, whereby user need to disable the parental control mode before the application can track the current location of the user using the GPS tracking. And finally, is authorization always. This is not the best practice because when using in this case, the application can collect the info of of the location of the user even when it's running on the background. Meaning it's not so it's not advisable due to the privacy issue. Let's say this one, right? Already authorized when in use, means we this is the case that we will choose for this lab exercise. So next we will going to the center view user location. We will be calling this function. Center view location is this function. It will display your location on the map. Center means like the blue dot will be center, and the longitude and the longitude zoom meter is in 10,000 meter. Okay. So for example, like let's say in the map, if the user is static, then this line of code will not run. Means like you just go to here, guide let location equal to location last seen and return back to the or result. But if let's say after the few seconds the system scan, the user is walking around, so it the dot the blue dot in the screen must be followed the staff location, the current staff location, the current user location. So these three lines of code that make the blue dot following the exact location is working. Meanings like it will be updating with the current longitude of the user based on the GPS service. Okay, and it will be animated as true in the map view. That's all for the GPS geolocation. Next, we'll be explaining about the database. Okay, finally for the database application, this slide, sorry. So finally for the database user registration here, I'm gonna go through some of the codes to build the database. Basically there's a 1, 2, 3, 4, 5, 6 files that we're using to create the database program. The important part that you need to explain is that you need to use the core data import library. You need to import the core data library into the Swift file in order for the database application to work. Okay, first of all, there's a basic rule to create the database. First, you need to import the core data library. Second, you need to store input data into the container, and then you need to save the input data in the table view, which is and make sure that the table view, the data in the table view is still there even if the application is closed and reopen again. And in doing so, you need to make sure you need to fetch the stored data in the container back into the table view. So you need to create a NS manager object subclass and has this Excel data model ID in order to have the fetch feature. Okay, I noticed that when building this application, there's a few roadblocks that I encounter, which is I don't have this XC data model ID, and also in my app delegate, I don't have this core data stack and also core data saving support. Basically, what happened is that initially when I create this Zahin RE calculator project, I didn't tick the core data checkbox when creating new project. Creating new project, you need to tick the core data. For example, like single view. Next, this one, use core data. If you didn't tick this core data checkbox, you will not have the XC data model ID, and also in your app delegate you doesn't have that two additional function that we need to be used for the core data application to run. Okay, but it's okay, you can just generate this project as a template and copy. I can just show you. You can just generate the template and just copy this line, this core data stack code, and also the core data saving code support features. And in order to get this XC data model ID into your project file, you just go to your folder, create new files, and if you scroll down a little bit, there's a core data model here. You just choose the data model and it will generate for you the empty XC data model ID. Okay, that's how you need to do if you you start a project without checking in the core data checkbox. Okay, let's go to the code for this lab. Since I already didn't check the checkbox at first, I copy the core data saving support and also the core data stack line of codes in the separate Swift file called persistent services .swift. Okay, as we can see, there's the important part, just like I showed you just now. Basically, in order to create a database type of application, you need to store the data into the container. So what I mean by container is like is here. You need to have cause these two line of code which act as a container to save your file. This line of code is responsible to save the uh, any context into the container. Okay, and uh, okay, just push the simulator here. Okay, you mentioned that this has the plus symbol, right? The add symbol. So add symbol is basically is the action button called on plus tab. Okay, so basically when we press this plus button, it will create a window, a small window saying the add person and stating the text field for name and age, and you can. Okay, so this is the line of code that is responsible for the small window that appeared on the simulator just now. Basically, uh, uh, and you can see that in the line 43 until line 47, 46 is where is where the input of when user key in their name and age is saved in the container that reside in the persistent services, which is in the persistent services.swift file here. Okay, so when you want to create a database, uh, you need to create the identity first called person and key in to the attribute that you want. For example, for this demonstration, I create age and name. Name is using string and age is using integer 16 because this is the smallest integer that I can select, because age is just around 0 until 150, something like that. It's not big number, so it doesn't need to use integer 32 or 64, and it's not possible to use decimal double or float, so integer 16 it is. So that's when you create the attribute, or you need to uh, generate the uh, objective C file called the NS manager subclass, object subclass. You can do that by highlighting the identity here and go to the editor, create NS manager object subclass. So you just follow the guide to say next, next, next until complete. What it does that the system will generate you these two files to objective C code file that represent the same thing here. You can see that have features to fetch the data from the database back to your UI kit table content. This line of code will fetch the data from the database from the person identity in the XC data model, stored in the XC data model, into the table view. I believe that's all that I want to present for this lab assignment. Thank you for listening and have a good day.